All right, in this video, I'll be doing question number 4 in homework section 8.2. It says, according to a study conducted by a statistical organization, the proportion of people who are satisfied with the way things are going in their lives is 82 hundredths or 0.82. Suppose that a random sample of 100 people is obtained. Complete parts A through E below. Suppose the random sample of 100 people is asked, are you satisfied with the way things are going in your life? Is the response to this question qualitative or quantitative? We would say that it's qualitative because basically you agree or you disagree that you're satisfied with how things are going in your life. So let's look for that. So it's qualitative because the responses can be classified based on the characteristic of being satisfied or not. That's perfect. Let's move on to the next part. Explain why the sampling proportion p hat is a random variable. What is the source of the variability? So it is a random variable because if you look at several samples of 100 people, you would expect that the sample proportion the sample proportion is going to be a little bit different. It's going to vary. And so that would make it random. And let's see what we got here. The sample proportion p hat is a random variable because of the value of p hat represents a random person. Now that's not it. The sample proportion is a random variable because the value of p hat, again that's same start. The sample proportion p hat is a random variable because the value of p hat varies from sample to sample. That's what I was just saying. And the variability is due to the fact that different people feel differently regarding their satisfaction. You're picking different samples and you're going to have different people, and because of that there's going to be some variability. So C is going to be our answer here. All right, let's move on to letter C. Describe the sampling distribution of p hat, the proportion of people who are satisfied with the way things are going in their life. Be sure to verify the model requirements. Since the sample size, we need it to be less than 5%. So let's go ahead and do that real quick. I'm going to go ahead and switch screens. And actually, I should have written down the numbers first. Let me do that. So our population size is 100. And it doesn't really tell us what the population is. So I don't know, we're looking at the population of the US or the population of Texas, but we can assume it's going to be a pretty large quantity. I think we can assume that. We're going to have to assume that. So we do 100. Well, actually 100 over a very big number is going to be less than 5%. So that's going to be met. So no less or no more than 5%. The sample size is no more than 5% of the population size. And let's find NP times 1 minus P, and we need to see if that's greater or equal to 10. Well, in this case, N is 100. P is 0.82. That means 1 minus P, well, 1 minus 0.82 is 0.18. And we want that product, 100 times 0.82 times 0.18, to be less than or greater or equal to 10. So 100 times 0.82 times 0.18, and I'm getting 14.76, so it's not a lot bigger, but it is bigger. So 14.76. So for that reason, because those two conditions have been met, the distribution of p hat is approximately normal with we know that the mean of this sample distribution of p hat is going to be equal to p, which is 0.82. And let's see, we got a formula to find the standard deviation of the sampling distribution of p hat. Let me go ahead and write the formula down, and then I'll switch. That's p times 1 minus p over n. So let me switch to my other screen. This is our formula to find the standard deviation. We already found the mean. What did we say the mean? Well, the mean is the same. Well, it's equal to p, which is 0.82. All right, so we've got the square root of 0.82 times 0.18, 1 minus p, which is 0.82, divided by n, which in this problem is 100. So let me go ahead and plug that into my calculator. I messed up at least once. There we go. So I'm getting 0.0384187. I forget how many places I need to go here. And it says 3, so it'll be 0.038. All right, so we have a normal or approximately normal distribution. We know the mean of our sampling distribution of p hat, and we also know the standard deviation. So we're ready to use our normal calculator. And that's what we're going to have to do next. It says, in the sample obtained in part A, what's the probability that the proportion who are satisfied with the way things are going in their life exceeds 0.86? So basically, we want the probability that p hat is greater or equal to 0.86. Exceeds would mean greater or equal. So let me go back here. So basically, this is the probability we are finding that p hat is greater or equal to 0.86. And let's go ahead and plug in our numbers into the calculator. So our mean is 0.82. Our standard deviation was 0.038. And we want to know when we're greater or equal to 0.86. So we get 0.14625. I think that should be enough. Let's go back to the homework. So 4 decimal places, so it would be 0.1463. 0.1463. The probability that 75, or let's see, using the distribution from part C, would it be unusual for a survey of 100 people, so n is still 100, to reveal that 75 or fewer people in the sample are satisfied with their lives? Well, p hat here is equal to x over n, which in this case is 75 over n, which was 100. So that's 0.75. So we want to find the probability that p hat, let's see, 75 or fewer, so it'll be less than or equal to 0.75. So I'm just going to show you the work that I did. So 75 out of 100 gives us the 0.75. So it's kind of nice with 100 for our sample, just because think of percent. This is 75 hundredths, that's 75 hundredths. So we want to know when p hat is less than or equal to 75 or 0.75. Let's go to our normal distribution. We still have 0.82 for the mean. Our standard deviation, let's see. Hold on just a second. Let me make sure I have this right. So the standard deviation doesn't change. We want to know when p hat is less than or equal to 0.75. So I'm getting 0.0327. Let me go back to the work here. So that is less than 5%. So the probability that 70, so we're still, so in E it does say we're using the distribution from part C, so so that didn't change. So our mean and standard deviation were unchanged. So the probability that 75 or fewer people in the sample are satisfied, we got 0.0327. It does say 4 decimal places down below, which is unusual because this probability is less than 5%. All right, and so that does it for question 4.